All right, here we go. All right, guys at home, can I get a thumbs up that you hear me and see the board okay? Is everybody all right? All right, here we go, guys. Chapter 7. We are starting. Where did I put my marker? Inverse functions. So we have the inverse sine, the inverse cosine, and the inverse tangent functions. Now you have to be careful because inverses are like a slippery slope. You have to be careful that an inverse, by definition, is a function. So we have to make sure that it behaves like a function. And remember, a function means that it's an input-output machine, but when you plug an input in, it only has one output, right? So if 2 goes in and 5 comes out, then when you plug 2 back in later, 5 still has to come out. It's not like you can plug 2 back in and now a 10 comes out. That wouldn't be a function, all right? So remember, an inverse function is going to be a function that undoes another function. And I put a little note. In order for the inverse function to exist, the original function must be 1-to-1, which meant it was a function that passed the VLT, the vertical line test, saying that the original is a function, but then it also had to pass the HLT, the horizontal line test. You don't want the original function's x's or y's being repeated, because the original function's y's become the inverse's x's. So if the original function's y's repeat, that means the x's for the inverse repeat, and now it doesn't behave like a function. So it had to be a 1-to-1 function. It had to pass the VLT and the HLT in order to have an inverse that could exist, okay? So remember, not all functions had an inverse that existed, because some functions have y-coordinates that repeat. They're not 1-to-1. So they can't have an inverse that would then be a function. So sometimes we had to restrict the domain of a function, like the parabola, y equals x squared, to make the inverse exist. If you guys remember, the parabola doesn't pass the HLT. He's not a 1-to-1 function, which is y equals x squared. So if you remember, we had to restrict his domain to just half of the parabola in order to make his inverse exist, which is the square root function. All right, so remember, if we want to make an inverse exist on a function that is not 1-to-1, then you have to restrict the domain to a portion of its graph where the inverse could exist, if it's not able to exist over the entire function or graph. All right, so the sine, the cosine, and the tangent functions, guys, they're not 1-to-1 functions. Their graphs don't pass the HLT. I mean, think of the sine curve, right? He just keeps repeating. He's not going to pass the HLT. His y-coordinates repeat all the time. So he should not have an inverse, okay? But unless we restrict their domains, then we can use a portion of their graphs to make their inverses exist. And guys, if you ever looked at a calculator, you know the inverse sign exists. We have an inverse sine function, right? It's like that sine raised to the -1. So you know it has an inverse, but it only has an inverse because the domain got restricted. We forced the inverse to exist only for a portion of its graph. So that means what the inverse sign is capable of doing is restricted. So we need to see what portion of each trig function's graph is used to make their inverse exist. We need to see how we say who survived the cut, what angles and what ratios survived the cut of its graph to make the inverse exist. All right, so we're going to do the sine function today. We'll get into cosine and tangent hopefully tomorrow. All right, this is going to be a little difficult because there's so many things I need on my screen at once, and I hope they all fit. All right, so guys, let's look at the sine function first. The sine function, think about how it behaves. You plug an angle into the sine function, and it spits a ratio out of two side lengths, right? O over h, or what was it? The y-coordinate over the radius when we redefined it, right? So the domain, guys, you were able to plug any angle you wanted into the sine function, and then a ratio came out between -1 and 1. So only ratios between -1 and 1 live on the sine curve, right? Because think about it, it's O over h. A small number divided by a big number will never be bigger than 1. Okay, let's look how he behaves. So guys, if I plug an angle between 0 and pi over 2 in, so if I plug an angle between 0 and pi over 2 into the sine function, a ratio between 0 and 1 comes out. That's how he's working right now. Then, if I plug, and those are your quadrant 1 angles, if I plug an angle between pi over 2 and pi in, So if I plug an angle between pi over 2 and pi in, a ratio between 1 and 0 comes out. Okay? If I plug an angle between pi and 3 pi over 2, those are my quadrant 3 angles. If I plug an angle between pi and 3 pi over 2 in, a ratio between 0 and -1 comes out. All right, if I plug an angle between 3 pi over 2 and 2 pi in, right? So from 3 pi over 2 to 2 pi, these are my quadrant 4 angles. A ratio between -1 and 0 comes out. And then guys, after that, everything starts repeating. These are quadrant 1 angles again. So now a ratio between 0 and 1 comes back out. Now I'm on my next interval. These are my quadrant 2 angles. So a ratio between 1 and 0 starts to come out. Everything starts repeating after that. And we can even go backwards. If I plug an angle between 0 and -pi over 2 in, these will be quadrant 4 angles when we rotate clockwise. A ratio between 0 and -1 comes out. Okay. So that's how the sine function works. You plug an angle in, it's going to spit out a ratio between 1 and -1 out. We need to figure out, though, the inverse can't exist over the entire graph. Because, guys, think about it. Here's the ratio of 1. Pi over 2 makes 1 come out. But so did 5 pi over 2 make 1 come out. And so did -3 pi over 2 make 1 come out. So, guys, if I inverse sine this, if I plugged the ratio into the inverse sine, and I said, hey, what's the inverse sine of a ratio of 1? I'm literally asking what angle had a sine ratio of 1? Well, technically, the inverse could spit out pi over 2. It could spit out 5 pi over 2. It could spit out -3 pi over 2, but that's not a function. It can't spit more than one angle out. So right now, the inverse can't exist because these y-coordinates repeat too much. So what we're going to have to do is we're going to have to chop it. We're going to have to chop a section of its graph that will pass the HLT, that will make it so the x's and y's do not repeat. So what section did we keep? Well, guys, you have tons of options. But it makes most sense to start at the beginning, at 0, and let's see what section of his graph can survive the cut, where we can make his inverse exist, where he passes the HLT. So guys, if we start at 0, and we're just looking at this red line, it's like, does it pass the HLT? Yeah, it's passing, it's passing, it's passing. Again, we're not thinking about over there yet. It's passing, it's passing, it's passing, it's passing. The minute you come up and around this hump, now it's like, oh, wait a minute. Now it doesn't pass the HLT anymore. Now it's hitting both sides of that hump. So we said, you know what? Then chop it. Cut it right there before it makes that turn. So we chop it right there. Now we start going backwards. Is it passing the HLT? Yeah. Pass, 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 pass. The minute you make this turn back up, now it's not passing the HLT anymore. So we said, all right, then we're going to have to chop it right there at -pi over 2. So this is the section of the sine wave that we use to make his inverse exist. We chop it at -pi over 2, and we chop it at pi over 2. And only this little squiggle right there makes the cut to make his inverse exist, which means ratios from 1 to -1 still live on this portion of the graph, so they survived the cut. All the ratios survived the cut, but the only angles that live on this portion of the sine curve are from -pi over 2 to pi over 2. So those are going to be the only angles that the inverse sine function is going to be capable of spitting out, because those are the only angles that survived the cut of its graph in order for us to make the inverse exist. So guys, if you ever used your calculator is programmed. It is only capable of spitting out an angle between -pi over 2 and pi over 2 whenever you use the inverse sine function, okay? However, there's lots of other answers when you have an inverse sine question. It's just the calculator and the function itself are only capable of telling you answers that are from -pi over 2 to pi over 2. Those are the only angles it can ever spit out. All right, so if we move our notes up, let's see, I have so much I want to still be on the board at the same time, but let's fill this part in. So it says, does this graph have an inverse that exists? Technically, the answer to that question is no. I got a little ahead, but if we restrict the domain, only use a portion of the graph, then the inverse can exist. So we need to take a smooth, continuous portion of the graph. We just did that. We chopped it, all right, where the inverse can exist. So if we restrict the domain from negative pi over 2 to pi over 2, then the inverse will exist. So just on that portion of its graph, that's where the inverse will exist. Okay. Therefore, the inverse sine function only exists for angles between negative pi over 2 and pi over 2, which are angles found in quadrant 1 and quadrant 4. Those are the only angles you're ever going to be allowed to put down as an answer to an inverse sine question. Okay? All right, here we go. So then it says, let's do the inverse sine now. Let's find the inverse. Now that we know what portion of the graph we're using, let's find the inverse. So guys, remember how you do that. To find the inverse, you take the original function and you switch the x and y's. So now the inverse would be x equals sine y. But remember, we don't want y to be the one living inside of the function and x being the one coming out. This is what we call the implicit form of the inverse. All right, we want the explicit, so you have to resolve it for y. And how do you resolve it for y? Who's going to undo the sine function and get y by itself? The inverse sine. You inverse sine both sides, and then the inverse sine and the sine cancel, and you're left with y is equal to the inverse sine of x. Okay, so that is the inverse function. It will undo whatever the original function was doing. All right, so now think about how the inverse is going to work. Now you're going to plug the ratio into the inverse sine, and it's going to spit an angle out as y. But guys, it's not going to spit any angle out. It's only going to spit out an angle that survived the cut. And the only angles that survived the cut are angles between negative pi over 2 and pi over 2. Again, when you are dealing with an inverse sine question, you have to think like it's programmed. It is only programmed to be able to spit out angles between negative pi over 2 and pi over 2. All right, so the inverse sine. Also, sometimes you'll see books, they write it as the arc sine. Arc sine x is the same thing as inverse sine. Arc sine is just another way of saying the inverse, because the arc, it's calculating, the inverse sine is calculating an angle, right? Now remember, when you're in radians, the measure of an angle is depending on how many radians or radiuses fit into that arc. So it's just because we measure an angle by the length of an arc now. So that's why it's arc sine, it's getting you the measure of that angle. All right, well, think about who the domain is. Now we're allowed to plug a ratio in, and all ratios survive. So negative 1 to 1 survive. I can plug a ratio from negative 1 to 1 into this function. So you can plug any ratio from 1 to negative 1 into the inverse sine. All the ratios survived. But then the range. What angles is it capable of spitting out? What angles survived that cut? Only angles from negative pi over 2 to pi over 2. So those are the only angles it's ever going to be able to give us as answers. Even though when we start solving equations, guys, there's going to be more than one answer. It's only capable of telling you one because it's a function. So it can only spit out one answer. All right, so it's going to be able to spit out angles from pi over 2 to negative pi over 2. Oh, I'm going to regret doing this here. I know I am. I'm going to have to redraw that. It's all right. All right, so if you think about the original graph, it used to be pi over 2 went in, and then in a ratio of 1 came out. Now, when a ratio of 1 goes into the inverse, an angle of pi over 2 comes out of it. If you look on the original graph, 0, 0, right? An angle of 0 radians went in, and a ratio of 0 came out. Now, a ratio of 0 goes in, and an angle of 0 radians comes out of the inverse sine. And then before, on the regular sine graph, you would take the sine of negative pi over 2, and a ratio of negative 1 came out. Now, a ratio of negative 1 will go into the inverse sine, and it will spit out an angle of negative pi over 2. Remember, on an inverse function, the ordered pairs reverse. So now, this is what the inverse sine graph looks like.
Oh, so that dot on the right is supposed to be for.
Yeah, I missed it a little bit. Sorry.
It's okay.
So it looks similar to that. That's what your inverse sine function is going to look like. So it's just, guys, it's just a small portion of the sine curve that makes the inverse. So his graph technically isn't, it's finite in a way that you have to end at angles between negative pi over 2 and pi over 2. I gotta move mine up, guys. I wish I had done this. All right, let me just redraw it really quick. Okay, all right, so now let's see how this one reads. So the inverse works like this. If I plug a ratio between 0 and 1 in, so if you plug a ratio between 0 and 1 into the inverse sine, it's going to spit out an angle between 0 and pi over 2, this leg of the curve. Which means it's a quadrant 1 angle. So if you take the inverse sine of a positive ratio between 0 and 1, it's going to spit out an angle in quadrant 1. So if we ever get in the future and we have to rework this and we have to put a triangle somewhere that deals with a question like this, you want to put that triangle in quadrant 1 because that's what angle it would have spit out. It would have spit out a quadrant 1 angle. All right, look at the other way. If I plug a ratio between 0 and negative 1 into the inverse sine, if I plug a ratio between 0 and negative 1 into the inverse sine, it's going to spit out an angle between 0 and negative pi over 2. Which means it's going to spit out a quadrant 4 angle because that's where angles between 0 and negative pi over 2 live. So in the future, if you are dealing with an inverse sine question and you are taking the inverse sine of a negative ratio between 0 and 1, that's going to spit out a quadrant 4 angle. So put the triangle in quadrant 4. All right, so here we go. So remember, the inverse sine function can only spit out angles between negative 90 and 90 degrees or negative pi over 2 and pi over 2 radians. Quadrant 1 and quadrant 4 angles. So guys, you're going to see me draw this a lot. Think of your unit circle. The only angles on the unit circle that survived the cut of the inverse sine are angles from pi over 2 to negative pi over 2. So just that little half circle is what we're able to use when we are working with the inverse sine function. Angles from pi over 2 to negative pi over 2. Ratios from 1 to negative 1. All right, so think about your special angles that live on this portion. We have pi over 2, we got 0 radians, and we got negative pi over 2. And then you also have your specials, your pi over 6, your 30, your pi over 4, your 45, your pi over 3, your 60. You have your negative pi over 6, your negative 30. You have your negative pi over 4, and you have your negative pi over 3, your negative 60. So those are the only angles that we're really ever going to be able to use without a calculator with the inverse sine function. That's all he's capable. Those are the only ones that are special to us that survived the cut of its graph. All right, so guys, look at this. So if you're ever asked the answer to the inverse sine of 3/5, well, guys, do you agree that 3/5 is a positive ratio between 0 and 1? So if you take the inverse sine of a positive ratio between 0 and 1, the answer to that we already know. It's a quadrant 1 angle. It's something between 0 and pi over 2. Okay, so now if you use your graphing calculator or any calculator, as long as it's in radian mode, if you take the inverse sine of 3/5, it's got to tell you it's some angle between 0 and pi over 2. And guys, pi over 2, pi divided by 2 is like 1.57. It's got to be a number between 0 and 1.57. That's 1.57 radians. So if you double check it, guys, on your calculator, the inverse sine of 3/5, it tells you it's 0.64. And where does 0.64 radians live? Somewhere right here in quadrant 1 between 0 and 1.57 radians, because that's how the inverse sine works. All right, we know the answer to the inverse sine of negative 2/3. If you take the inverse sine of a negative ratio between 0 and negative 1, the answer to that question is somewhere between 0 and negative pi over 2. It's some quadrant 4 angle. So now ask your calculator, what is the inverse sine of negative 2/3? And it will tell you it's negative 0.74 radians. And where do negative 0.73 radians live? Well, here's 0 radians, and this is negative 1.57 radians. So negative 0.73 is some angle between 0 and negative 1.57. It's a quadrant 4 angle between 0 and negative pi over 2. All right, so that's all he's capable of doing. So keep reminding yourself, the inverse sine function is only capable of spitting angles out between pi over 2 and negative pi over 2. This little half circle right there is all that exists for him. All right, let's try some examples. So you shouldn't need a calculator until the very, very bottom of the notes. All right, here we go. So guys, let's say they asked you, find the exact value. What's the inverse sine of 1? Well, guys, think about it. You plug a ratio in to the inverse, the answer has to be an angle, but not any angle. It's only an angle from negative pi over 2 to pi over 2. So guys, think about it. We had 0, 1, 1, 0, and 0, negative 1. And then you had all your little specials in there too. All right? The inverse sine of a ratio of 1. Well, it's basically asking you the sine of what angle had a ratio of 1. So what angle between pi over 2 and negative pi over 2 had a ratio of 1? Anybody know what special angle it was? Who had a y-coordinate of 1 between pi over 2 and negative pi over 2? Pi over 2. The answer to this question is pi over 2. That's the angle that the inverse sine function would spit out. And since 1 is one of our special ratios, we do not need a calculator for this. Go ahead, Michael.
What if you throw right next to the sine sign?
Angle. It's an angle symbol.
Oh.
The sine of what special angle had a ratio of 1? I turn my inverse sine questions into sine functions, so I can think of it like that. All right, look at this one. The inverse sine of a ratio of negative 1 equals what angle? The answer to an inverse question is an angle. So then I always say, all right, well then the sine of what angle had a ratio of negative 1? So guys, what angle between pi over 2 and negative pi over 2 had a sine ratio of negative 1, a y-coordinate of negative 1? What angle would it be? It's right there. A lot of students think, oh yeah, 3 pi over 2. The sine function can't spit out 3 pi over 2, even though he's an answer to this question. He would only be able to spit out what angle? Negative pi over 2. So there's more than one answer to these questions, except the inverse isn't capable of telling you all the answers because that's not a function if he spits out more than one input. All right, look at this one. The inverse sine of root 3 over 2. Well, guys, I hope you realize that the inverse sine of that ratio is going to equal an angle, but not any angle, right? It's a positive ratio. It should equal a quadrant 1 angle. So now you have to ask yourself, the sine of what quadrant 1 angle equaled a ratio of root 3 over 2? Guys, the only ones they can ask you out of a special or with no calculator, it has to be a special. It's got to be a 30, 45, or 60. All right? So think about it. Oh, not that. What special angle had a sine ratio of root 3 over 2? Was it a 30, a 60? It ain't 45. We should know that by now. It's root 2 over 2 or 1 for cosines and sines and tangents of a 45. So guys, what special angle had a sine ratio of root 3 over 2? That would be your 60. That would be your pi over 3. And that's an angle between pi over 2 and negative pi over 2. So he'd be capable of spitting it out.
So that's the 30-60.
Yep. Mm-hmm. All right, look at the next one. The inverse sine of a ratio of negative 1/2. Well, guys, we should know. If you take the inverse sine of a negative ratio, the answer to that question is a quadrant 4 angle between negative pi over 2 and 0. It's somewhere in there. So, guys, what special angle had a sine ratio of 1/2? So the sine of what special angle had a ratio of negative 1/2? You only have to worry about the negative. We know the angles in quadrant 4. What one had a ratio of 1/2? That would be your 30, your pi over 6. And that's an angle that the inverse sine is capable of spitting out. It's an angle between pi over 2 and negative pi over 2. Oh, guys, wait, call me out on that. it's got to be a quadrant 4 angle. So it can't be pi over 6. It has to be negative pi over 6. Sorry about that. All right? And that's how we work it. You have to remind yourself, I have to think like the inverse. I'm only capable of spitting out angles between pi over 2 and negative pi over 2. All right, this is where they're going to throw some monkey wrenches at you. Guys, look at this one. They want you to find the inverse sign of the sine of pi over 8. Let's break this down. The sine of an angle is a ratio. The answer to that is a ratio. So then you'd be taking the inverse sine of a ratio. The answer to that is an angle, but not any angle. The inverse sine is only capable of spitting out angles between pi over 2 and negative pi over 2. All right, well, guys, let's go back. What should the inverse sine do to the sine function if they're really inverses? They should cancel each other out. And you're just left with that angle, which our answer is an angle of pi over 8. But now you have to check, is pi over 8 an angle that the inverse sine would be capable of spitting out? Is pi over 8 an angle between pi over 2 and negative pi over 2? Well, guys, in the world of pi over 8, this is 8 pi's over 8, right? All the way halfway. So that would be, half of that would be 4 pi's over 8. Where's 1 pi over 8 going to be? In quadrant 1, somewhere between 0 and pi over 2. So that is an angle that the inverse sine is definitely capable of spitting out. So he's your answer. Nice and easy. All right, look at the next one. We need to find the inverse sine of the sine of 5 pi over 8. Okay? Well, guys, the sine of an angle is a ratio. The inverse sine of a ratio is an angle. The answer to this question is definitely an angle. Okay, but what angle? All right, well, what should the inverse sine do to the sine function? They should cancel. And I'm left with the angle of 5 pi over 8. Hold the phone, guys. Is 5 pi over 8 an angle that the inverse sine would be capable of spitting out and telling us? Does 5 pi over 8 live between pi over 2 and negative pi over 2? Guys, if this is 4 pi's over 8, where's 5 pi over 8 going to be? In quadrant 2. So 5 pi over, don't leave, please don't leave. 5 pi over 8 is a quadrant 2 angle. It couldn't spit that out. It cannot spit out a quadrant 2 angle. So we got to fix this. So remember, all students take calculus. All students take calculus, right? The sine function is positive in 1 and 2, and he's negative in 3 and 4. Well, we just took the inverse sine of a positive angle, right? So we're in quadrant 2. So you need to take this quadrant 2 angle and move him to his equivalent spot in quadrant 1 that he would be capable of spitting out. So guys, what's your reference angle? If this is 8 pi over 8 and this is 5 pi over 8, how many pi's over 8 live in between them? 3 pi over 8, which means that the sine of 5 pi over 8 is the exact same thing as the sine of 3 pi over 8 because it has the same reference angle. So that means we have to convert this to the 3 pi over 8 angle that lives in quadrant 1 that he would be capable of spitting out. So the answer to this can't be 5 pi over 8. It's the reference angle that would be equivalent to him that lives in quadrant 1. So the answer to this is actually 3 pi over 8. He would not be capable of spitting out that quadrant 2 angle. So you have to find his equivalent one that lived in quadrant 1. That's where they can get tricky. All right, guys, listen to this. I think what I'll do is, I don't know what to do with the homework. I started a homework, and I just don't know if I'm happy with how far I got. I only have a few more to do. I'm going to assign it. It's not due till Wednesday. I'm going to assign the homework if you want to start working on it. I'll finish these notes tomorrow. It's just a few more examples, and then I'll get into the inverse cosine. So if you don't finish the homework because I didn't get to that type of question yet, you'll still have till Wednesday to get it done. All right, these sections are just long, and there's so much information. Is everybody okay with that? All right, so guys, remember, inverse sine can only spit out angles between pi over 2 and negative pi over 2. They are the only angles that survived the cut. All right, thank you for staying, guys. Please, if anybody gives you an issue, guys, please tell them that I kept you, and they can call me. All right? All right, at home, let me just double check your attendance, guys. The bells are 2 minutes fast here, so you should be joining your other classes 2 minutes early. I'm sorry.